Hello and welcome to your channel AWS Cloud Bytes. Today we are going to talk about create and configure a network load balancer in AWS. I'm your host Bhavesh Kumar. If you like these videos, please like, share, subscribe and click the notification bell icon for future updates. Your comments are welcome for making these interactions much better in the future. So as we already said, we are going to create and configure a network load balancer in AWS. As part of this exercise, we'll create and configure a subnet. We'll already have a subnet and we're going to create another subnet. After creating subnet, we'll edit the network ACL or NACL for short. We'll create two EC2 instances, one in each subnet. And then followed by that, we are going to create and configure a network load balancer for servicing traffic to both the EC2 instances. Once we are done with this, we can test and monitor the network load balancer. Let's begin. It's lab time. Okay, I have logged into an AWS management console. Before we start, let's see what all infra we have. I will open AWS VPC. So you can see that we have one VPC, there is one subnet, and there are two route tables. Click on the VPC. We have this VPC, and if you click on this VPC, you can see that this VPC is having only basic info. There is no flow logs. And if you look at our subnet, you can find one subnet which is associated with the VPC that we just saw. And then you have a route table here associated with this. Now, we also have an internet gateway assigned to this VPC. So those are the resources that we already have. These are the pre-configured resources. We are going to create a subnet now. Select our VPC. And we can see the CIDR block. And the name of this VPC can be public again with a B. And I'm going to choose US East 1B. This can be 10.0.2.0/24. I don't want to add a new tag. These are optional. So we give the availability zone, CIDR block, and that's it. You created a new subnet. Once you have created subnet, you will see public and public B, two subnets showing up. Click on the newly created subnet. And scroll down towards the route table. We need to modify the route table so that we can go to the internet. It needs a route to the internet gateway. So let's click on the route table. And if you click on the routes, let's edit the routes. Add a route to all zeros, 00/0, and this should be internet gateway. Egress only. Internet gateway is for IPv6. We are just going to use IGW regular internet gateway and save the changes. Now click on subnet association, edit subnet association, and it is associated with public B subnet already. Once you are done with the editing of route, you can see that the subnet association, after editing the subnet association, the subnet ID is showing up here. And this is the CIDR block that we defined for this particular subnet. Once we are done, we are going back to subnet. Click on network ACL. And click on the network ACL link. It opens the network ACL. Select that. Click on the inbound rule. Edit the inbound rule. Let's update rule 100. We have HTTP is what we are looking for. And let's do HTTP port 80. This is good. Let's add a new rule. 101. This is again HTTPS. This is good. Allow rule. Then we are going to add another rule. These rule numbers are the order of evaluation. This is custom TCP. We can choose protocol. TCP 6 is there, which is good. And the range that we are going to open for is 1024 to 65,535. 1024. And again, open to everyone on internet. We can save the changes. Look at the inbound rules. So we have modified rule number 100, which is HTTP port 80 and port range 80. Allow 101 HTTPS. Allow. Then you have 102 custom TCP 1024 to 65,535, and this is an allow. And following these three rules, all other traffic will be denied. Now we are done with the updates in NACL. Let's go to an EC2. Let me search EC2 as a service. Open that in a new tab. We are going to launch a new instance, and we want to give a name like web A. We are good with Amazon Linux. This is all good. T2 micro is good. I'll download a key pair. Instance type is here, key pair is here, network setting is here. I think I need to modify this. VPC is good. Subnet is public A, or you can say just public. This is the initial subnet in which we want to launch this. Auto assign public IP is enabled, and I will go and create an instance. Before doing that, I need to insert some user data script. Now what this script is doing is it is doing an yum update and installing HTTPD and enabling that HTTPD. Then you have Apache. This is just modifying the access, and once you're done with that, shambly echoing request handle by web A to an HTML file, just writing this text in an HTML file so that whenever the request is given, this index.html when loaded shows up on our responses, whether it is a browser or it is a console response. Over here, security group, I need to see if I selected the right one. I want to select an existing one. There is already a existing security group, so I'm gonna select the security group, basically EC2 security group. That looks good. We don't want to change anything on the volume or disk. Everything looks good. There's no other setting that I'm gonna change on this. Everything is defaulted. Just the user data, be careful about that. And you can do a launch. Now this launch is in progress. Let's go and create another one. You can see there is an admin instance. This instance has been used as a Bastion host or a jump box. Let's launch another instance, and this name will be web B. Same Linux machine, nothing change over here. T2 micro, I just want to keep T2 micro. And the key value pair, I'll just use the one that we created just now. Edit this to be on the 1B AZ. The first one was hosted here. I want to host it in a second. AZ, the new subnet that we created. Enable auto assign public IP. Use a security group that is already available. And in the advanced, I will go and create a similar user data script where we are doing a yum update, installing an HTTPD, enabling that service, writing request handle by webB to this index.html file so that we know that this request was handled by webB. And this looks good. I'm gonna create a new instance. Okay, look at the instances. So first one, web A, is initializing. Second one is, let's wait for a couple of minutes. It will take some time, maybe 5 minutes or so, to get initialize and health check done. I'll pause the video. Okay, I waited for a couple of minutes, maybe 3 to 5 minutes, and it looks like it has initialized. Both the instances that we created are now up and running. Let's go to create load balancer. Before we create load balancer, let's recap. We created a public subnet. We edited NACL for that public subnet. We modified the routes to allow port 80 and port 443, which is HTTP and HTTPS traffic. We also allowed ports between 1024 to 65,535, and rest of the ports were denied. So we did that modification, and then following that, we created two instances, web A and web B. Both of them are created with existing service group and in each subnet. So public subnet A, which was an existing subnet, has one instance running. The subnet B has another one. They are in two different availability zones. You can see 1A and 1B. Now we are going to create a load balancer. So let's go and create a load balancer. Click on the load balancers and click on create load balancer. We are going to create a network load balancer. So create on a network load balancer, and we can give any name, NLB test. What we want is an internet facing load balancer. We don't want it to be an internal load balancer. We are going to support IPv4, not both. Let's select a VPC. We have one VPC. We can select that VPC. Once you have selected VPC, this is the mapping that you have to do. You have to select what AZs and subnets in each zone that you want this load balancer to have access. So I'll select US East 1, and then you have 1A, you have one subnet, public, and then 1B, you have another subnet that we created, which is public B, and these are all IPv4. In the listeners and routing, you need to create a target group. I'm going to open that into a new window. So in target group, you need to define who is going to receive this traffic. In our case, we are going to send this traffic to instances. So this target type is correct. Let's go further. Which VPC? We have only one VPC, which is pre-selected. And then this health check is good. Let's click on the next. Oh, I forgot the name. NLB targets. Click on next. Now we want web A to serve traffic and web B. This is just a Bastion host or jump box, we are going to use it for testing, so we are not going to select that one, and we can say include as pending below. You can see these two are now added to the target. We'll go and create a target now. Let's see the target group. Currently it is saying unused. Let's go back to the load balancer and refresh. I'm on the load balancer page. Refresh the drop down. You will see NLB targets showing up here. Select NLB targets and going down, you create a load balancer. Oh, let me just give NLB test without any underscore, create a load balancer. So the load balancer creation is in progress. It will take some time. It is provisioning. I'll pause the video until it is provisioned. Okay, after waiting a couple of minutes, I refresh this. You can see the NLB is in active state, and if you go to the target groups, this NLB is using is all in healthy state. Now I can go to this NLB test, network load balancer, and copy this DNS. Open that DNS in a new tab and try to hit it. So the request handled by web A, it's all by web A right now. Let's test it out using a script now. I'm going to open a terminal. So this is my Mac terminal. I'm gonna use SSH cloud underscore user at the IP. I'm gonna copy a password. What I can do is I can do a small curl just to hit this particular DNS. So this is while true, do curl. I'm gonna take the DNS name. And hit it. We are generating a lot of traffic. You can see web A and B both are getting response. The requests are going to both instances, and the responses are coming from each instance in two different AZs, those two public subnets that we have. We have response such as web A and we have web B. Now we should look into what kind of metrics we have generated. So we can go to the monitoring. I just broke out of that particular script, otherwise it will run in a loop and it will generate a lot of traffic. So I'm still waiting for this to start showing all the logs, and you can see that finally it has started showing logs after a couple of minutes. You can see new flow count. You have graphs of the capacity that was consumed, how much data was processed, and yeah, it didn't refresh everything. That's why it was showing provisioning, but hopefully. So you see a bit of data. If you go to instances, the EC2 instance, if I select web B and click on monitoring, you should see some activity over here. You can see that the CPU utilization was higher and then it went down. network in bytes and out bytes, packets in and out. Similarly for web A, it should have similar graph because the load was balanced in both the subnets in two different AZs. Network in, out, packet in, out. Pretty consistent graphs. Now, as part of this lab, what all things we have done, we want to recap before closing. So we started with VPC. When we opened a VPC, there was one subnet in the VPC. We created another subnet called public B. In the public subnet, there was already a running EC2 instance that we used to run the script for generating traffic. This lab was also having an internet gateway associated with the VPC. Once we were done with the creation of subnet, we modified the NACL, which is here. For public B, we modified the inbound rules, number 100, 1, and 2. You can see it is now HTTP and HTTPS, and then we allowed traffic to these ports, and rest was denied. So we modified the first one, added 2 rules. Once we were done with that, we went ahead and created 2 different instances, web A in US East 1A, while web B in US East 1B, and both have their own public IPs. Once that was done, we created a load balancer. We created a target group that was associated with the load balancer. You can see we have this NLB targets, and NLB targets has EC2 instances, the 2 EC2 instances that we created, both associated with this particular NLB targets. So what happens is when the request comes in, it is sent to an NLB target, and NLB target knows what all instances are going to serve the traffic or process the incoming request. Once that was done, we used a terminal to actually log in. I can show you what we did. Okay, so what we did was we logged in SSH in the Bastion host or the jump box, and after logging in, we ran this script to just hit on this particular public DNS, that is a NLB DNS, and it was giving responses served by both the instances. This is the end of this lab. Please share your comments and suggestions. Thank you for watching. If you liked the video, please like, share, subscribe, and press the notification bell icon for future updates. This is your host Bhavesh Kumar signing off. Thank you.